Okay, so this is the most famous theorem that we have to prove. This is Pythagoras' theorem. So it says in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So let's draw a diagram to see what we have. So often with this, the first thing to remember is that we probably want to draw or we may want to draw it like this, kind of a line down right angle triangle, and you'll see the reason why in a second. So that's a diagram there. We've got a triangle ABC. We're given a triangle ABC with the measure of the angle BAC equals 90 degrees. Okay. Doesn't matter which angle you put as the 90 degrees, but probably put it up the top. And you'll see why in a second when we do the construction. So to prove, so we want to prove that the hypotenuse squared, so that's BC squared, is the other two sides squared, so is AB squared plus AC squared. And now the construction. So what we do is we drop a perpendicular from A. So we're going to draw a line from A perpendicular to BC. And we're going to call this D. Alright, so let's just do that, and then we're going to talk about how we're going to use it. So draw line from A perpendicular to BC, and it cuts BC at the point D. And we're also going to mark in some angles to help us. So let's mark in 1, 2, 3, and 4. So mark angles 1, 2, 3, 4. Alright, now there are two steps. First of all, we're going to look at the big triangle, so ABC, and this triangle ABD. And we're going to show that ABC and ABD are actually similar triangles. They have the same angles. And because they have the same angles, we can write down ratios of their sides. Okay. The reason they're going to have the same angles is that if you look at ABC, the big triangle, it's got a right angle, it's got the angle 1, and then it's got another angle. And this triangle ABD, it has a right angle here, it has the angle 1, and it has another angle. So that means ABD and ABD and ABC must be similar. They must have the 3 same angles. You can't have 2 the same and 1 different, so they have the 3 same angles. So because of that, we can write down some ratios. The second pair then we look at is we take a look at ABC and the right hand triangle ADC, and we show that they're also similar for the same kind of reasons. They both have a right angle, they both have this angle 4 in them, so they must be similar. So we write down some ratios, and then when we put the two ratios together, we end up with Pythagoras' theorem. So let's do that. When we're doing it, it can be useful to draw out separately the triangles we're looking at. So first, so proof. Is that on screen? No. There we go. Proof. Okay. We're going to look at the triangle ABC and the triangle ABD. So here's ABC. It's got a right angle up there. It's got the angle 1 here. It's got the angle 4 there. So A, B, C. And just so we remind ourselves, it's got that point D there on it. And then over here, we've got ABD. A, D, B. It's got the angle 1 there, and it's got a right angle there. Okay. So the angle 1 equals the angle 1, because it's common. It's in both of them. The angle ABC is equal to the angle BDA, because it's right angled. Okay, in one of them it was given, in the other one it was by construction. Therefore, the three angles match because the angles in the triangle add to 180. So you can have two matching and the other one not matching, since the three of them add up to 180. So the three angles match, so the triangles are similar. So now we need to decide what sides to use. So when we're trying to decide what sides to use, the first thing is we're going to use the hypotenuse. In each of these we use the hypotenuse. So over here, let's use the hypotenuse. So we're going to use BC. And it doesn't matter, we can put the hypotenuse in this one divided by the hypotenuse in this one equals blah blah blah. That might be a good way to do it. So the hypotenuse in this one is BC divided by the hypotenuse in this one is AB. Well, that's equal to, and what we do is, because we've used AB here, we're going to use the AB here as well. Alright, so hypotenuse over hypotenuse equals AB here. The only question is which side over here corresponds to that AB. So AB here is across from the angle 4. So the one corresponding to it will have to be across from the angle 4. Now that's the angle 1. That's the right angle, so it's got to be the side across from this angle. So it's that side BD there. Okay, or if you like, AB here is between the right angle and 1. So the side here between the right angle and 1 is the side BD. So this is what we get by similar triangles. What we're going to do here is we need to get rid of the fractions because there's no fractions in Pythagoras' theorem. So we're going to multiply both sides by BD times AB. We multiply this by BD times AB, seeing as that's the common denominator. On the left hand side the AB's cancel, on the right hand side the BD's cancel, and we're left with BD times BC equals AB squared. AB times AB is AB squared, and we're going to call that 1. Now we're going to do a very similar thing with the second set of triangles we're looking at. So instead of looking at instead of looking at the whole thing and the left hand, we now look at the whole thing and the right hand. We're going to do the exact same thing. Alright, so let's do that. I'm possibly going to run out of paper. So in the triangles ABC and ADC, so again let's sketch them out. So here's ABC again, right angle up the top, 1 here, 4 here. Let's mark in D just to kind of remind ourselves where we are. And ADC is this bit, the right hand bit, so that's still the angle 4. So in these two triangles, the angle 4 equals the angle 4 because they're common. Alright. We have a right angle in both of them, so BAC equals ADC because they're both 90 degrees. Therefore, the three angles match because the angles in the triangle add to 180 degrees, and therefore the triangles are similar. So let's go through a similar thing to the last time. Once again, let's take a look at the hypotenuse. So therefore, BC over AC this time. Alright, so the hypotenuse here, BC, divided by the hypotenuse over here, which is AC. Now because we use AC here, we're going to come back here and use AC in this triangle. Now AC is between the right angle and 4, and over here the side between the right angle and 4 is DC. Alright, so hypotenuse over hypotenuse equals this side divided by this side, so AC over DC. Alright, we multiply both sides by the common denominator, so multiply by AC times DC AC, DC. Go ahead. And you end up with DC times BC equals AC squared. On the right hand side we have AC times AC, which is AC squared. And that's equation number 2. Pretty much finished at this stage. You've got all the heavy lifting done. I'll just get some more paper. So the last thing, actually we'll use the smiley face sheet. So the last thing that we need to do now is we need to put those two together. So let's find them. One said that AB squared is BD times BC, and 2 said that AC squared is DC times BC. So let's add both of them, because in our answer we want AB squared plus AC squared. So let's add them. So we get AB squared plus AC squared on the left equals BD times BC plus DC times BC. Alright, now looking at the right hand side, difficult to see there, so let's move that over a bit. So looking at this right hand side, you can see that they have a BC in common. So let's factor out the BC. So that's BC. I've taken down that wrong, haven't I? That should be BD, sorry. So we've BC into BD plus DC. Alright, so there's one more line. So the only thing that we have left to spot is that if you go back to any of these, you can see that BD plus DC is just the length BC. Alright, so we have BD plus DC, that's just that length there, BC. So this right hand side is really BC times BC, which is BC squared. And we're finished. AB squared plus AC squared equals BC squared. And that's Pythagoras' theorem proved. So a very quick recap. There's 3 steps. You drop down a perpendicular, so we'll go all the way back to the start. You drop down the perpendicular from A, put your right angle at the top, just makes it a bit easier to drop the perpendicular. Drop a perpendicular down. You show that the whole triangle is similar to the left, and do a little bit of similar triangle ratio stuff. You show that the whole triangle is similar to the right, and do another bit of ratio stuff, and put the 2 ratio things together. When you're doing the ratio things, put the hypotenuse in the big triangle over the hypotenuse in the small one, and then that tells you what other sides you need to use. Okay, so just remember, for instance, back here we put BC, the hypotenuse, over AC, the hypotenuse here, and then because we were using AC here, we said, well, let's use AC in this triangle. So that was AC that joins a right angle in 4, so that's the same as DC over here. Okay, and we did the exact same thing down here. The trick is to try and remember as little as possible. So you just remember, use the hypotenuses, and then kind of follow what that tells you to do. So BC divided by AB, and then because we were after using AB over here, we came back and we said, well, we'll use AB here. That joins the right angle in 1, so we use the one joining the right angle in 1. Put them all together and just remember that BD plus DC is going to be BC. And that's Pythagoras' theorem.